Hey everyone, welcome back to my channel. As we begin, I would like to think about a genetic condition that blends unique physical characteristics with hearing loss, Waardenburg syndrome. Waardenburg syndrome is not just a medical diagnosis, it's a fascinating case of how genetics influence traits we can see, like eye and hair color, and those we can't, like hearing ability. Waardenburg syndrome is a group of genetic disorders characterized by two main features: congenital hearing loss and changes in pigmentations. These pigmentation changes can be observed in the eye, hair, and skin. It's important to note that these symptoms can vary significantly, making diagnosis dependent on a combination of physical examination and genetic analysis. One of the hallmark features of Waardenburg syndrome is heterochromia iridum, a condition where the irises of the eyes are different colors. For example, one blue and the other one is brown. So heterochromia iridis basically means the existence of two different colors on the same eye. So these two features reflect a distribution in melanocyte distribution during development. In clinical practice, striking hair changes such as white forelock or premature graying often draw attention. These are not just cosmetic differences, these are key diagnostic indicators. When coupled with hearing loss, these features strongly suggest Waardenburg syndrome. Skin depigmentation, such as patches of lighter skin or areas of uneven pigmentation, is another characteristic feature. These changes result from a reduced number of melanocytes in the affected areas, which also explains the pigmentation-related eye and hair abnormalities. So as we can see from this little child, he has got blue eyes. That's because melanocytes didn't develop. So we can see from this little girl's photo that she has got white patch on her hair. That's because melanocyte didn't develop. So we can see from here too the depigmentation of the eyes and the hair at certain parts. So here we can see white patches as well on his hair, and in addition to that we can see heterochromia iridum. One eye's color is different from the other. The syndrome is divided into four types, each with distinct features. Type 1, for instance, is associated with wide spacing between the eyes and less frequent hearing loss. In contrast, Type 2 lacks this eye spacing but has a higher likelihood of hearing impairment. Type 3 includes limb abnormalities, while Type 4, also known as Waardenburg-Shah syndrome, is linked with Hirschsprung disease, a condition affecting the intestines. Waardenburg syndrome is rare, affecting about only 1 in 40,000 people. Despite its rarity, it accounts for 2 to 5% of congenital hearing loss cases. The genetic mutations responsible for this syndrome affect melanocyte development and are found in several genes, including PAX3, SOX10, and MITF. The inheritance of Waardenburg syndrome is typically autosomal dominant, meaning a single altered gene from one parent is enough to cause that condition. However, there are autosomal recessive cases requiring mutations in both gene copies. Additionally, some cases arise from de novo mutations with no family history. From a clinical perspective, the prognosis for individuals with Waardenburg syndrome is generally good. Life expectancy is normal, and most individuals adapt well to any hearing loss with proper interventions. Early diagnosis and supportive care can significantly enhance the quality of life. If this video intrigued you, don't forget to like, subscribe, and join me next time as we uncover more mysteries of medicine. See you next time.